Welcome to Chapter 10, Section 3, entitled Area of Parallelograms. To begin with, let's recall something about parallelograms. Parallelograms. They are quadrilaterals. Another thing about quadrilaterals are opposite sides are equal. Congruent. Opposite angles are congruent. And opposite sides are parallel. So what that gives us, please remember, is a shape this side is congruent with this side. This side is congruent with this side. This angle is congruent with this angle. And this angle is congruent with this angle. Now, if all of this is true, then this side here and this side here are parallel, right? This is a parallelogram. Parallelograms can also be considered a rectangle because, again, congruent, 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 same, same. All the things are still okay. But this is what most of your parallelograms will look like. So, the key concept is that the area of a parallelogram is the product of any base and its height. So you're going to have a parallelogram There's your parallelogram. And it's going to have a base. And any of these can be the base. But you really should look at it as the bottom part of this parallelogram. Then the height, that's the tricky part. The height is not the side length. All right? It's not going to be how long the side is. It's going to be the height from the base to the top. All right? And the reason that works is because if I took this portion right here, and I just cut this portion out. See, I cut this out, and if I come over here and put it right here, what it would form, remember we cut that part off, here's the top still, here's the bottom, but then this over here moved to here, this part moved right here, and now what you have is a rectangle with base times the height. So, the base of a parallelogram can be any one of its sides. So whatever side you want can be the base. The height, though, is the shortest distance from the base to the side is the height of a parallelogram. Oh, to the top side. So here again is a parallelogram. Okay. This would be the base. This would be the top. The height would be the shortest distance right there. Now, if I took this parallelogram and decided I wanted to look at it like this, well, now this is no longer the base, this is no longer the top, this is no longer the height. The base is now the bottom part, this is the top, and the shortest distance right here is the height. The shortest distance from the top side, from the base to the top side of the parallelogram. All right, so taking a look at this, remember that the area formula, maybe you should add this in here. Go ahead and add this. The formula for parallelograms is area is equal to the base times the height. So area, base times height. Now, replace b. What is b? b is this distance right here. So count those squares. 1, 2, 3. The height is from the top to the base. So that's 1, 2, 3, 4, 10. So the height is 10. So replace those. The base is 3, the height is 10. When you multiply, it's 30. So the area is 30 square units, or 30. Find the area of each parallelogram. All right, again, area formula. Base times height. The base is 8. The height, it tells us, is 5. So we plug those numbers in there. 8 times 5 is 40. The area is 40 square meters, square centimeters, or 40 centimeters squared. So this would be units squared. I'm going to make a big deal about the units, making sure you put the units on. All right, so let's find the area of each of these parallelograms. For the first one, we need area parallelogram. Area of a parallelogram is the base times the height. Well, for A, the base is equal to 1, 2, 3, 4. The height is equal to 1, 2, 3, 4, 5. The height is 5. So, area is equal to base times height, or 20. And when it says units, it should be 20 square units, or units squared. Base times height. Part B. Again, area of a parallelogram. Area equals base times height. The base, 6. The height is 3. So when we plug that information in there, area is 6 times 3, or 18. So the area is 18, but when I put the units in there, they're square inches. All right, let's review this. Write the mixed numbers 10 halves and 6 1/4 as decimals. So 10 halves, well, all we care about is the fraction, 1/2. If you know what 1/2 is as a decimal, it's 10 and 1/2. As long as you know what that is as a decimal, like 0.5, then you have 10 and 0.5, which would be 10.5. 6 and 1/4. Let's pretend we don't know what 1/4 is equal to. So we actually have to say how many times does 4 go into 1? It doesn't. So we have to, it goes in there 0 times. So we drop down, the annex a 0. 4 goes into 10 twice. That's 8. 2. Annex another 0. 5. 0. 0.25. So you would say that this is equivalent to 6 and 0.25, or 6.25. Please make sure you put this work in here. All right. Find the area of the floor that the rug will cover. The area rug is a parallelogram, so use the formula A equals BH. Parallelogram, BH, base times height. The base is 10.5, so 10.5. The height is 6 and 1/4. And actually, we can make this 6.25. Okay. Now, there are two things we could do. We know that area is equal base times height. So area is equal to 10.5 times 6.25. And you could multiply those by hand. And get 65.625. Okay? So you could have an answer of 65.625 square feet. All right? But we also have learned to multiply fractions. 10 and 1/2 is equivalent to 2 times 10 plus 1, 21 halves. 6 and 1/4 is equivalent to 4 times 6 plus 1. And so now you're multiplying 21 halves times 25 fourths. And now you can just do a smaller multiplication. Five 25/8. So either way will work. I would say, since if we're trying to find the area of this, if you just looked at this and you could say it's about 66 square feet. All right, almost done. So here is the area of a mural that John needs to paint.